Hola, hola comunidad, ¿cómo están? Estamos acá con Danilo, que es brasilero, es arquitecto de plataformas distribuidas y también da mentorías en Java. Ayuda a los desarrolladores a crear arquitecturas escalables y robustas para que puedan contribuir los mejores productos, construir mejores productos y lograr resultados asombrosos. Hoy nos va a presentar su charla Demystificando el patrón Circuit Breaker con Microprofile, donde nos contará estrategias para la adopción del patrón en ambientes críticos. Así que, sin más preámbulos, I leave you with Danilo here, and I hope we can enjoy his awesome presentation.
Oh, yeah. Hey,
You can
Andreas,
start.
thank you for the introduction. Hey, hello, Java community. It's a pleasure to be here. So it's my first time at the Peru Java community. Thank you for the space, Carlos and Andres. Really glad for this opportunity. So today we are going to talk about demystifying the circuit break pattern with microprofile. So I don't know who of you are watching this talk, but left a comment here on the comments if you have ever used any kinds of implementation you use trying to implement the secret break pattern. If anyone has ever used that, so just leave a comment on the YouTube channel or in the LinkedIn page so we can just get your feedback on that. Okay. Yeah, I see some people doing some reactions here. Oh, nice. So yeah, also I like to ask people if maybe a bunch of you are working with some distributed architectures, or let's say some microservice or distributed monoliths architecture. And I already asked about the circuit breaker pattern, but who of you know about what is the microprofiling specification and what are the tools and implementation that you can have if it is spec? Does anyone has ever tried that? I have seen that there were other talks related to microprofile. Although I know that one Java champion today, Juan Wosco, is going to talk about that later in our schedule. So do not miss his presentation about that. If anyone has ever tried that, so just leave a comment here or send some reaction on the chat, and we can understand more about that. Oh, nice. Great to see you guys. Okay, so yeah. Uh, so before we start our presentation and talk about circuit breaker and microprofiles, I just would like to highlight the most important thing. So let's start from the beginning and let's talk about what is resilience. So when we talk about circuit breakers, when we talk about microprofile, what are the kinds of problems that they help us in our architecture? They help us to solve a problem. So there is one thing called resilience, which for me is one of the main pillars in our architecture concepts. And this is one of the things that I would like to start talking about. So, and for that, I would like to know if who of you that's watching this presentation has ever thought about how to make your architecture more resilient, if you are worried about that on your day-to-day work, how you do that, and what are the most important things that you can take from it, the most advantages that you can take from that. So, okay, just leave a comment or make some reaction if you are using that, if you are worried about your architecture resilience. Oh, okay. So, you can see some comments here. Nice. So, just going to the architecture concepts, let's talk about resilience first. So, if you go to the dictionary and take it and try to read the real meaning behind these words. So what does that mean? So it's an ability to recover or adjust easily from a misfortune or a change. So let's think about that. There is one, I like to think about when you need to go from one place to another, and then just some traffic jam happens in the highway, and then you just need to think about, okay, so there is a traffic jam in the highway. I got this information from my Google Maps or Waze or any routing application that you can use. So the first thing that you think about is that's okay. How can I understand that there is a traffic jam, and how can I think about getting a different way or adjust my routes to my destiny to achieve the goal of getting there as soon getting to the place as soon as possible. So how we do that? So this is what does resilience mean, and this is we're just getting this information from the dictionary. So it's not much. There is not a big correlation with association with our architecture change, or let's say to our technology area. So to understand more about how and what does resilience means in the architecture area, in the technology area, I would like to mention one example from Sam Newman. I don't know who of you have ever heard about Sam Newman, but he wrote these two excellent books. So if you are words about, want to learn more about microservice, wants to know more about distributed architectures, I strongly recommend reading his books. So in this way, in this case, I just sharing these two books, but I know that he's many other books. And from then I took this phrase. So resilience within microservice architectures intends creating systems that can absorb and recover from failures, providing the ability to scale, evolve, and continue functioning under various conditions. So yeah, it's not that easy to understand that. I know that at first we can just read this phrase and say, oh man, what he's talking about absorbing, recovering, failures, scaling, evolving. So let's just go deeply and try to understand that. So the first thing that calls my attention at this phrase on what is resilience, there's one meaning which is absorb and recover from failures. So what does that mean? So that basically means that when I shared the example that you want to go to one place to another and then a traffic jam appears, let's say that traffic jams could represent a failure. So when you think about resilience, absorbing recovery from failures is the way that you understand, that you capture the failure that's happening on your architecture and understand what you are going to do with that. So let's think about not one failure, but let's think about that your database starts to get the queries starts to get slowly and slowly. So how would your application, what would be the behavior of your application when this kind of thing happens? Or let's think about with another example, which is, let's talk about Java applications. So we have one Java application, it's running, and from 1 minute to another, the CPU consume starts to grow. So all the I/O operations starts to grow, or the threads start to grow, the number of threads used on your application starts to grow. Then this is something that your Docker container, your instance might have a limit for CPU and also for memory. Then what you're going to do with that? If you are not able to control what's going on your Java application, probably you're going to have an out of memory problem, or even one out of resource problem which is related to the CPU consuming. So this is what we can talk about from absorbing and recover from failures. So just going further for the next point that I would like to highlight here. So the ability to scale and evolve, so when we get our failures, we understand the failures, we understand the problem, the situation that's going on in our context, we should be able to provide the ability to scale and evolve. So let's think about the example that I mentioned about the Java application that had some CPU problem. So what would you do on that case? So you can try to scale your application for a new container. You can try to provide a more CPU resource for your Java application before it crashes. So you have a lot of things to do. You can even try to, if you want to do that, I'm not really sure if people recommend doing that, but you can just try to force one one garbage collector to run our Java application or something like that. So this is what your the ability of what you can do to over the failures that you are getting, understand them, and then provides a way to scale or evolve that. And the third thing that I would like to highlight is under various conditions. So what does that mean? And this is pretty interesting because I just wanted to share one example that happens this week. So I have some of my teammates. They work in Florida, from Florida, and I don't know how much of you, but some of them they just messaged on Slack saying telling that there was a warning because of a tsunami in that area. And hey man, what does that mean? You know, it was the first time that I listened people talking about that during their work, and I just said, "Whoa, a tsunami! That's crazy, man! How would you? What would you do on that?" And my first question for them after they were able to get into a safer place was, "Hey, how was that? What you did on that condition? You know, because it's not something that we can control. So when we take a look at our architecture and just think about one example. You know, we were at the last week, if I'm not wrong, was happening all around the world the Black Fridays. And at one previous experience, I remember that on Black Fridays we had a really high traffic on our applications. So I just could think about that. You know, a day before the Black Friday, I would just tell to my friend, "Hey, tomorrow might happen a tsunami of new requests on our application, on our architecture. So what we are going to do about that?" So this is what is about under various conditions. So we can't control our environments. We can try to predict some things as we could predict with the Black Fridays, and then we had all the work to provide new resources before the Black Friday provides new resources to our applications, and then it would scale with a better results than just growing and not being able to scale. So when we take a look at San Emil phrase, I like to understand all these insights. Of course, he was able to describe all what I shared with you in only one phrase, but it's important to understand all the meaningful parts of this phrase that responds what is resilience for us. And then just going next, let's just wrap up on all that I talked about, and let's understand more what's resilience. So there is one thing that I would like to talk about. That's it. No, we are talking about resilience most because most related with architectures and applications and Java applications. But let's think about, you know, in our day-to-day work, you know, we as a persons, we need to be resilient as a person and not as our code implementation or architecture implementation, but we can, as person, as human beings, be resilient there as well. Once I asked to a friend that he do not work at all with technology. He works in other kinds of in other industry, and then I was talking that I went to do a presentation about secret breakers and resilience and all this stuff, and then he thought, what do you mean resilience in technology? No, and then he shared with me that in his perspective, from a person that works with people, he told me that for me resilience is a way to not freaking out when some problem is happening, and then just calm down and try to take a breath and understand what we can do based on the circumstance that we have in our context. So this was an amazing explanation about resilience that we can also take this into consideration when we think about architecture and technology. So resilience is based a way to handle failures, handle increasing over workload as the Black Friday tsunami or something like that, or and also under different chains, different conditions in our architecture. So resilience is all about that. So and just interesting, because this is one architecture concept that has so many ways to be implemented. That's it. We need to understand what are the best ways or what are the ways that fits better with our technology, fits better with our team, with our company. So today I'm here to talk about some practical examples about resilience and also share some the concept of the specification of microprofile. So just think about one practical example here. Let's go deeper and think about that. We have two different microservices. Both of them they communicate with each other using HTTP requests, and service B has one database. So when we think about an example where both of the servers they are communicating with each other, here I have one graph showing the throughputs of service B application. So service B is receiving a lot of requests from service A, and then we can see on the graph some spikes of throughputs or some requests in our service bay. And then here we can just take a look and say, oh, something is happening on service B. Maybe the database is not dealing well with the workload of the requests that we're having in our applications. And then we can just try to compare there. And we can say, oh, something is happening with service B. It's getting a higher throughput. We are getting some spikes of requests, and also we are getting some errors on that. So what's happening with service A? So service A is the service that is sending some requests from service B, but service B does not have only this dependence, so other microservice can send requests to service B, and also service B has his own workload to process some asynchronous messages. So what would be happening if service A at this kind of example? And let's think about resilience. Is service A resilience enough to deal with the failures that service B is responding for it? Or what's going on? So let's take a look at service A. So here we can see that service A has also a high throughput. Here I remember that this application, it's a graph from a real application in a previous experience that I worked on. We were having something like almost 5 to 10 million requests per minute, and that was a lot of requests. And here we can see that even that service A has some dependence on service B, he was also being able to respond some of the requests with some success stats, but at the same time, some of the requests were getting errors. So when we think about resilience, were service A resilient enough to handle with external failures or with the failures of his dependence? So let's take a look at the graphic. So, and it's pure coincidence that all the spikes from service B was able to affect service A, and at the same time that both of the servers were working together, the failures of service A rose at the same time that the failures with service B. So to answer that question, maybe at this case, service A wasn't resilient enough or didn't have the best approach to implement resilience in that case. And then one thing that I like to think about, so just bring up one problem that circular breaks helps us to solve, is the famous HTTP hell. So the HTTP hell is the failure of a chain of multiple synchronous calls in multiple servers. So here I have one example using 2 microservices, but let's think about it. Our entire architecture, that time I was working in a company, and our architecture had more than 3,000 microservices in production. So yeah, with 2 microservices, we have this kind of graph. I can't manage with, we had more, maybe 10 microservices, maybe 20 microservices. That's it. By the end, on the chain of requests between them, they were requesting service B. So maybe the entire architecture would be in troubles, because if one service fails, all the others that had some dependence on it would fail at the same time. So all the alerts would just start to alarm and send a warning related to that. So this is the HTTP hell, and how we can try to prevent that. So I just, for instance, I really like the "this is fine" emoji because if you have this kind of problem in architecture with a bunch of microservices, well, man, there's nothing to do. No, you just need to try to focus on the microservice that's failing, and sometimes it's not that easy because you can see maybe, let's think about that. For each microservice you have one specific dashboard. Then if you have 10 microservices, you have 10 dashboards to try to track where is the root source of the problems, of the failures. So it requires some techniques to make this kind of tracing, of monitoring, but it's not that easy. So that's why I like that this is fine meme, and think about that. So the HTTP hell and this is fine meme, or they have a perfect match with them. So yeah. So just going there. So here's the first implementation that can help you to avoid the HTTP hell, which is the circuit breaker pattern. So not only about talking a microservice pattern, but I like to think about the circuit breaker. It's much more resilience pattern because you can implement it anytime, not only with microservices, but also with monoliths, with serverless application. This is one of the partners that help you to avoid and help you to enhance the resilience of whatever you are doing. If it's an application, if it's a Lambda, or even if it's a monolith. So to understand more about the the circuit breaker pattern, this is one pattern, or let's say a component that can interrupt the flow of currents in circuit to prevent damage under certain conditions. So I really like this image. So this image represents a lot. I don't know if you know about what is that, but here in Brazil, this is one component that connects the electrical cables from the street. So the way that the city provides energy for the house, this is the components that connects this way into our house. So if we need to connect our get any kind of electric energy into our house, we need to use that, and it prevents from both of the sides. If it happens any problems from both of the sides, it prevents it helps to isolate the problem and not let it propagate to the other components. So if there is any problem on the cables that provides electrical energy to my house, then this problem will not be propagated to my house. And at the same time, if I had any electrical issue at my house, I hope that I would not never had that before. So I hope that I never had it in my life. But if any electrical problem happens in my house, it will help to not propagate it to the entire city energy electrical energy provider. So this is a way to prevent to propagate this electrical problem energy, and it has all about the circuit breaker. So I like to think that maybe the circuit breaker pattern came from it, and we are just implementing that in the same way in our architecture, in our application. So when you think about that, it's a way to analyze some errors and applying a semaphore and fallback rule into how to handle what's going on. So what does that mean? So let's think about it. That's it. The circuit breaker has a flow. Then at first the circuit breaker is closed. So it means that all the requests will be sent to the to the to the destination that we want to to send them requests. So think about the previous example, service A and service B. Service A will be making the request, and as the service B responds with a success HP status, or if success in any way, then the circuit breaker will keep closed. So all the requests will pass through the circuit breaker without any problems. And then when the service B starts to send some errors on the message, on the request, it starts to respond responds with some errors. Then the circuit breaker usually has some rules to understand how to deal with that, and it has some kinds of an algorithm to measure if it should keep closed or if it should go to the next status, which is open. And open means that, okay, I'm open and I will not let any message pass for the next service. So that means that once all the requests from, not all, but let's say the the amounts of requests that service B is responding with error will trigger the algorithm to change the circuit break status to the open status. And then with that, not all the message will be sent to the service B. So it will start to control what message will be sent and what message will not, until that it just decides to be open, and then not not all the message. I mean, almost 99% of the message will not be sent to the service B, and then this message will trigger a fallback or any kinds of other implementation. And once the circuit breaker is open, I mentioned that's not all, so 90% of the message will not be sent to the service B. Then there is this 1% message that are sent, that are being sent to the service B. They are a kind of a test request. So the circuit breaker left some message go to let some request to be done, and then he starts to make some tests with the response of the stats. So think about the relation, the communication between service A and service B. Once the service B starts to recover from the problem that was happening on, then the request starts to return success. So this 1% of request from the circuit breaker, we understand that this message will be on success, and then the circuit breaker will change the stats from open to half open. And then once it's on half open, it starts to measure all the success messages with the algorithm implemented behind it. And then once it achieves some of the gates for that algorithm, it can change to close it or to failure. So this is how does the circuit breaker works. Of course, it's not as the same as the circuit breaking in our houses to distribute the electrical energy, but it's the way that we at the architecture, it's the way that people had thought about, so how we can think about how we can implement a component like this in architecture and still have some response from that. So talking about that, we can find some implementations of a circuit breaker. So I don't know, most of people, that's when we talk about circuit breaker, I remember that some years ago, I remember maybe in 2014, 2015, when there was KickOn here at Brazil, and Netflix was the biggest company in the industry, sharing some thoughts on how to implement some of the microservice patterns. And then I remember when people just did some presentation on KickOn about the hystrix and how Netflix built that and what was the usability for that. And it was amazing because hystrix is still one of the most famous circuit breaker in the market. And the curiosity about that is that it's deprecated since 2018. So it's been 6 years that people not deprecators or are not getting more support for hystrix since 2018, and people still talk about that. So that means that Netflix did a great job about implementing that. And also we have other ways to implement, and I strongly recommend you to, if you want to implement a circuit breaker and you are using hystrix, think about migrating for one of these implementations. So we have the resilience for J and the microprofile fault tolerance. Both of them, they are open source, and the community around them then are really active, really open for new suggestions. And also the code base is open source. You can go there and just take a look at it and see how it's implemented. And also, I like to think about that. The community around them, well, they are amazing. So I can think about the Microprofile is supported by Eclipse Foundation, which is one of the biggest open source communities, open source organizations in the world. So they have more than 100 people contribute for the project that works for Eclipse Foundation, and then they are also one of the organizations responsible for the Jakarta implementation. So they are they are the open source organization behind of the Jakarta implementation. I don't know if people knows about that, but it's one of the most recent specifications that we have at the Java community in the past years. So at this implementation, I'm going to share some thoughts about the microprofile and fault tolerance. So I just will switch here my screen and show some codes about that. For that, I'm going to share a project which is using OpenLibert and Jakarta implementation and also microprofile. So if you are curious about how to implement that, I just will show some piece of code with that. So let me see here. Share screen. Okay. Yeah. Oh, okay. Oh, thank you, Anders, for switching that. Okay, so here at the project, just going to share, what are the dependencies here, and it's not that hard to create that. You can just go to the Open Liberty sites and create that. So here, not using the most recent versions, but I know that Jakarta is already on version 11, and Microprofile is on version 7, if I'm not wrong. So it's just a project that I have one technical debt to handle with this version here. So you just need to add these two dependencies, and then you'll be able to build your application using Jakarta and Microprofile. Also, just placed some other depends related to RESTs and JSON binding. And here I have some other configuration related to the circuit breaker. So the OpenLibert plugin to build my jar, to run my Java application. So yeah, so going there, this application is one application that would be look should be looks like the service A example that I was giving. Don't know if you remember, but it was the service A requesting service B and service B delivering some response from it. So service A has also some endpoints that it's exposed, and at these endpoints we have the logic to make some calls into some HTTP requests to service B. So here we have some examples about that. And what I want to share here is like, maybe some of this you might be just take a look and say, oh yeah, it's just requesting one singleton and then switching between the conference name here. So I was at the Open Community Experience, that's where I gave the same talk. I just forget to switch it to our Java community talk. And then we can go to the implementation of our HTTP client and understand how does the circuit breaker with microprofile fault tolerance works. So here we can just take a look at this class. This is the OCX conference HTTP. So this is one class responsible to send the request to our service bus, or let's say to the OCX API and request something from it. So maybe a resource or a data model, we can just make this request. And then to implement the circuit breaker here, we have basically 4 annotations that we should understand and how they are used. The first one is the circuit breaker annotation. So if you go there, take a look, the circuit breaker annotation has some values that you need to pass as parameters. And here I have some notes related to that. So the first value that you need to use for that is the request volume threshold, which is the number of consecutive requests in a window. So when you think about that, we are the circuit breaker, the circuit breaker analyzes the requests that we are doing for our third-party API. So it's split it in some windows. So it can be a time window, it can be a threshold window. So at this case, we have a request volume threshold, which is responsible for the consecutive requests. So in this example, every 25 requests, our circuit breaker will make some analysis with his background algorithm and understand what if it should change the circuit breaker status from open to close it, to close it, to half open, to half open, to close it. So this is the way that it will start to measure that. And also there is one failure ratio, which is basically the number of failures that are acceptable and on that slides window, on that rolling window. So let's think about that. Under these 25 requests, we are going to accept at least 10% of failures. So it means that every 25 requests, 2.5 requests will be acceptable to failure. More than that, the algorithm might be thinking about to change the circuit breaker status, and that's okay. So the next parameter here is the delay. So the delay represents the time that the circuit breaker will be open until it checks, until it runs the algorithm and checks if should change from open to half open or from half open to close it. So this is the delay time. It's in milliseconds. So it means that I'm just letting my circuit breaker to run that for 15 seconds. And the next pattern, which is also the important one, is the success threshold. It means that it's the number of consecutive invocations of that search that are required before the circuit breaker is closed. So if you want to request to have more response with success, you need to set up this success threshold to a higher number of requests. And also remember that this setup needs to be cleared, needs to have some aspects of this volume threshold. So if you are always working with a volume threshold of 25, the success threshold, if you set up it to 25, that means that the 100% of the requests should be success to change the circuit breaker starts. Then the failure rate will be nothing because you are not going to have the 10%. So calculating the success threshold is something important for you to be able to understand more about that, to understand more about when you can think about changing the circuit breaker status. And another important annotation that's used with Microprofile fault tolerance, it's the fallback. So what does that mean? Along with you remember that the image with the circuit breaker status, but when the circuit breaker is on the status open, all the requests that are not sent to the microservice to their original destiny, they if you have this annotation on your methods, it will trigger the fallback. So at this case, I'm telling that I'm going to set up a fallback, which will be the representation of this method. So I'm going to this method soon to explain that. And it will be only applicable when I get these exceptions from my HTTP request. So if I got the connection exception or a circuit breaker open exception, it means that it should trigger this fallback when the circuit breaker is open. Just for example, the fallback here is just, I didn't make any implementation for that. Here, in this case, it's just returning one string, let's say this example. But when we think about a real case scenario, I remember that we had some fallbacks set up when we had some database connection problems. So if you had a database connection problem, or if we also had some problems when we made one HTTP request from one service to another, one of the approach to implement a fallback would be to, for example, make a request to one static API that could be, for example, a file, a JSON file into the S3 that would contain the information that it could be not the most updated information that we had. And also it could be, for example, depends on let's think about one real example where we are buying something, where we have one application which is a marketplace, and we have some problems with the payment system. So if you have different payments providers, so it could be Mastercard, it could be Stripe, or any of that. If you start to get problems from Mastercards, then a fallback would be to use the implementation to Stripe. And then if you had a problem with Stripe, you can have another fallback implementation using any other financial API to handle with your payment system. So this is one example that it could be a fallback, and then you can have a chain of fallbacks that you could implement with that. So the fallback is pretty useful. I also like to think about that. So not more important than not just letting the error being thrown to your entire architecture, is also being able to think about a fallback. So the example that I mentioned about going to the destination to destination B, and your Google Maps just show that there is a traffic jam. The fallback is when you think about getting a different route to getting into your destiny on time. So the fallback is also important. And then here I just wanted to share another example related to the circuit breaker, which is maybe the less possible config, which is the skipion. So if you have one exception that you know how to deal with that, and this exception is acceptable, so let's think about that you are making requests from service A and service B, but sometimes the service B requests some authentication token, and your token just expired. So you don't want to your
Sorry,
circuit breaker. Oh, hey
sorry,
Andres.
Danilo. Yes, I could you reduce your window so it looks bigger, or increase the font size because it's hard to read in the YouTube stream.
Oh, sure. Oh, I'm sorry for that.
Yeah, no problem.
That's
Sure, thank you. Let's
Let me
see.
see. Oh, actually, I never remember how to do that.
That is better. That is better. I believe with CTRL plus would or Command plus if you are on Mac OS.
Command plus, let's try.
It's not working. So, yeah.
No, it's not going.
Or command dot command dot.
Oh, no.
Okay, no
Command
problem.
out.
It's good enough there.
Oh, okay. Oh, I'm sorry for that. I should have. Okay. Oh, sorry for that, Andres. Maybe I can try to zoom. Oh, okay. So just keep going with that. So when we think about that, on that example that we have on API that requests some of token, and we don't want to our structure breaker counts the authentication problem and not close that because we know that sometimes the token might disappear or something like that. And then we can just set it to skip on some specific exception, and then it will not be useful. The circuit breaker will not be applicable on this kind of exception. So just going here, I just will run the code. Let me see if I can. I'm sharing here. Yeah. Oh, I hate when this kind of thing happens. Oh. Do how much time do we have? Oh, okay, it's running. Let me try. Okay. Oh, not running. Yeah. Just will get this. So one example that I will share here, probably you're going to see the logs from it, is related to getting some requests. So what I'm doing here, I'm just using my Postman to send some requests to the circuit breaker. So I just looking for the OCX Eclipsicon, which is one of our resources. So here we can see that we send the resource and then we try to find that, and then we are getting the response, which is the OCX 2004 OCX Eclipsicon. So it's getting into this method, and then this method has I have some rules to evaluate our requests. So always when I do some requests, I just implemented one HTTP counter, and then depends on the example, it will triggers the circuit breaker or it will trigger a failure for that. So it will send just a bunch of requests for a microservice and wait until that hit count starts to give some failure. So here you can see the fallback. So what's going on here? So for this example, I implemented that not that it's a rule, but forever 5 seconds. So forever ever 5 seconds, the hit counter will count all the requests, and if it achieves more than 5 requests, if you just throw on exception, and then our method should evaluate the fallback method. So in this example, just shared that I made a lot of requests, and then for this requests that were faster. Oh,
Okay. Hey, Danilo, sorry, but we are running out of time. Do you want to take some time to answer questions?
Oh yeah, yeah. If we have some cash, I
or
would love to do that for sure.
round up first. But yeah, we have. Yeah.
Yeah.
So so so
So Frankie, right? Yeah.
or choose the one you want and yeah.
Oh, let's answer this first one. So Frank asked, what monitoring and alerting practices are essential to evaluate the effectiveness of circuit breakers? Oh, that's a good one. So, when you think about circuit breakers, we usually can think about, how we are going to write a unit test for that. And I have to share that it's not that easy. Also, while trying to use the presentation and think about how I would trigger the circuit breaker, it was not that easy. So I will share the link with the code for you. There you can find some explanations. So the point is, I believe that for circuit breakers and for any resilience pattern, it's not that easy to implement a unit tests, then I like to think that the integration tests in our architecture would be useful for that. So not only that, when I talk about integration tests, there is a bunch of tools that we can use and some concepts. The most that I like it is related to the chaos engineer. So for example, when we think about chaos engineers, how to measure how our application will survive into the chaos. So one of the practices is doing performance tests. So you can try to create some performance tests, and then in the context of building performance tests, you can think about pushing a lot of requests that you try to trigger a circuit breaker configuration, or let's say how is almost the same way that you are going to test if your auto-scaling configuration is working. So when you think about circuit breaker, no performance tests that will get some stress on your architecture. This is the best way that you can test and create monitoring alerts for circuit breaker. And also for monitoring, all these all the examples that I shared, so high streaks, microprofile, and resilience for J, they are integrated with Metaversity. So and also with OpenTelemetry. I know that is going to be a talk about OpenTelemetry by Juan. So he's going to talk about OpenTelemetry, introduction to OpenTelemetry. So you can get these insights, these metrics from these implementations, which are integrated with these circuit breaker libraries. Um, oh, Frank did a lot of questions here. Yeah.
Yeah. Do you want to choose another one?
Oh, let's go to the first one. So, what role does redundance play in building releasing systems, and how can it be optimized? Redundance play. What role does the redundance play in building resilience? Oh, that's a good one. So it depends on what you mean by redundance in your in resilience systems. But I like to think that if you have one architecture and microservices are calling each other for different things a bunch of times, so it can be redundant because why you have two microservices making requests for each other's for a lot of information, then it could be better to have a third one and to think about that. But think about that, we can think about having a better design of our domain driven design or of our domains and what are their responsibilities. So this is one of the thoughts that I have about it.
Well, thank you very much, Danilo. Sorry, we are out of time now. But yeah, thank you very much for taking the time to do this on a Saturday. It's most precious time for everyone. So it's thank you again, and well, thank you for all the people that are watching, and especially to Frank for the nice and interesting questions. Yeah,
Oh yeah, yeah. Oh, thank you, Andres. Thank you, Java community in Peru. So it's a pleasure to be here and hoping to be in presence next year at JConf Peru. I hope we can get more support for that. I can say that here in Brazil we are at the Soul Java community, and you know, having these communities, these Java communities all around the world, is really special. So we can change our experience, we can change insights about Java, and also be able to build our own community related to that. And thank you, Andres, for hosting the talk.
Okay.
It's a pleasure
Thank you.
to have you here. Hoping to see you in Brazil soon. So
Soon, I can go. Well, see you. Think
see you.
again.
Bye bye.
See you.
Thank you.
Bye bye.